Hi everyone, the following is a video review of the 3 PowerPoints that we have on the agenda for the activity isometric sketching, starting with line conventions. Now that we're talking about more technical types of sketching techniques, we do have some specific types of lines that we use to identify different features on a part. So that's what this PowerPoint is going to go through. The second one I'm going to talk to you about is the isometric and oblique pictorials that you see here. And obliques are another style. We won't practice it as much, but certainly isometric is more like our bread and butter, so we'll practice that a lot. And then the third PowerPoint here just has some tips on how to sketch out a isometric circle or ellipse, anything with a rounded edge to it. So going back to line conventions, let me start this one up. And so as I was saying, we have different types of lines that can convey different types of features on a part. And so lines of varying style and thickness are used in specific ways to develop and communicate graphic messages about an object's geometry. The next several slides will show what those types of line conventions are and how they are used. So starting with a construction line, as it might suggest, a construction line is just anything that can kind of help frame out the actual object to kind of give you some space and proportion while putting in your actual sketch. And these are typically drawn very lightly because you don't want them to take away from your object lines and the rest of the actual sketch. But it's really just used to kind of help guide the drawing of other lines and shapes. The next one here obviously would be an object line. These are much thicker and darker, and they will help define the edges of the actual object that you're sketching. Third one is a hidden line. Hidden lines are used to show interior detail that might not be visible from the outside of the part. So for example, here, this part has a hole on each side of it. This one you'll notice has some diagonal lines here. That means it's been section viewed away. We'll talk about that in another slide here. And that's why these lines here for this hole are solid, because we've actually cut away the part and we're actually looking inside of that. On this side, we have not cut away any of the part, and so that feature would be shown as a hidden line. The hidden line is dashed and has a gap in between it. So you have equal like segments, line segments, when creating your hidden lines. Next one here is a center line. This will go with any kind of rounded object or hole or anything like that, but it helps define the center of arcs, circles, or even symmetrical parts, half as thick as an object line. So you try to draw them a little thinner than your object lines. And for the center line, the thing here is you'll have one dash right in the middle and then two longer dashes. It's not a hidden line with as many as you can fit in between the space, only 3 segments, one right in the middle, one on top, one on bottom. And notice that those ones on top and bottom actually extend beyond the object line and the actual part. So center lines kind of stick up and out. You can see one here on the left side. And on this slide, you'll see a center mark. This will be used when you're looking directly at a circle or a feature like that. So it's kind of like top down looking straight at it. Again, it's used to define the center of arc circles and symmetrical parts, but here it's a little different. You're kind of basically taking two of these center lines and overlapping them into a plus symbol here. You have a plus in the middle and then 4 extensions going further out from there. A section line, as I mentioned a moment ago, this is used to define where material has been cut away. And so this is something that we can do in our software very easily. Much harder to draw a section view out, by hand and trying to envision a part in front of you and like mentally cut it away and then draw that. It's much harder to do that. So we don't really make section views by hand, but we will make quite a few of them using our software for the year. To go along with those section lines, we have a short break line. This is a freehand drawn line, shows where the part is being broken or kind of cut away to reveal any of that detail inside of it that we're looking at here. And so it's just a squiggly line all the way down, showing the 2 halves of the part, where it's been cut and where it's not been cut away. This is a short break line. They also have a long break line. Long break lines can be used when you have very uniform objects and you don't want to take up an entire page just to fit them. And so, for example, here you'll notice this part is dimensioned at the bottom, these 5 cubes are 1.25 inches, so each one of these would be 0.25 in length. And then here saying it's 12, and obviously we did not traverse that many squares. So this long break line is saying, hey, in between the left side and the right side of this break, the part was uniform. There were no changes in the profile or anything like that. So instead of having to draw the entire 12-inch part out, we can put this little long break line in here and then make it smaller and fit on the page. Not too typical to see this done. I mean, we don't really find ourselves in situations where we do it, especially with our software or anything like that. But it is interesting. I kind of liken it to the Charlie Brown symbol on his T-shirts, this little zigzag here, or maybe even like a heartbeat readout on a heartbeat monitor, something like that. All right, and the next one here is dimension lines. This will show actual distances. Arrows are drawn on each end of it to show where the dimension line starts and stops. And then the actual distance is typically then located in the middle of this line to display that. So again, you have your distances here, your arrowheads, and then the lines that are actually coming off the part, those are called extension lines. So this shows where the dimensions start and stop in relation to the actual features of the object, used with dimension lines. And then there's typically like a 1/16 of an inch gap between the object lines and your extension lines. So these little gaps that you see here, that's just to make sure we're not confusing anything with the actual part. Leader line, these are used when we're dimensioning radiuses and diameters and any special notes or anything like that. And so this will typically be drawn in with an arrowhead and a line at a 45-degree angle and just come straight out from there. And then you can attach your dimension information. So you have the diameter symbol there and the number 2 in inches, half of an diameter, half of an inch in diameter here, 1 inch diameter, and then also added in some information about how deep it was. So all of that can get tagged onto a leader line. This is a cutting plane line. It's used to show cutaway views or plane of a projection where a section view has been taken. So we had that like short break line a few slides ago and created a section view with that. In our software, we can actually drop in these cutting plane lines and cut something directly in half or in quarters, wherever we want to actually cut it, we can, and create additional views this way. And so that type of line, which is kind of dashed top to bottom, and then does have an extension beyond the object lines, top and bottom here, and then it will show either left or right, up or down, whatever direction you drag your mouse in, essentially, to create that view. That's the part of the object you're then going to see. And so that is a cutting plane line. All right, line conventions. These standards relate to technical drawing. They'll hopefully be more precise than any freehand sketching techniques you've used in the past, and use these standards as a guide when you are sketching. Okay, now we do have a kind of a hierarchy here when dealing with all these different line types, and you're going to find situations where certain lines and features of an object will end up lining up with other features on the object and other types of lines. So when that happens, we have some things that we can fall back on. Line precedence must be used. So starting with object lines, take precedence over hidden and center lines, meaning if you had a hidden or center line drawn in and then realize you're going to have an object line right over it, draw the object line. That's what we're going to see. Next one down is hidden lines take precedence over center lines. So again, if you have a hidden line and a center line that are in the same position, we want to make sure that we see the hidden line more so. And then the last one here is cutting plane lines take precedence over all other lines. So when you drop a cutting plane in there, it'll just cover everything that's in its path. Okay. And then here's some examples of that. This is a feature or a part here that's shown as a multi-view. And here they're saying at the top, an object line has the precedence over a hidden line. The hidden line would be from this circle feature you see in the front view. So in the top view, this is that hole going through the part. And normally we would have dashed lines here for hidden lines. However, right above that hole, we have this little U-shaped cutout here. And these corners, 1, 2, 3, 4, are actually going to be lining up right in the same spot. So we have an object line taking precedence over a hidden line. On this sign, we have an example of an object line taking precedence over a center line. So again, we have our hole here in the front view. We have our center mark. You can see in the top view, you have your center line. Well, out here in the right side view, for projecting things correctly, it'll have a center line here as well. And I can see some evidence of that. I have little extensions sticking out here on the left and right side. However, this corner that I can see clearly in the front view will then be drawn out as an object line all the way in here on the side view. So object line taking precedence over center line. Okay, and that is the end of this presentation. I'll just quickly page over here to isometric and oblique pictorials. All right, so pictorial drawings, these are 2D illustrations of 3D objects. They will help show 3 faces of an object in just one view. And this provides a more realistic view of an object. And there are 3 types of pictorial drawings: isometric, oblique, and perspective. Isometric, we will practice a lot. Obliques and perspectives, not so much. We will work on identifying obliques and perspectives and figuring out what are the defining characteristics that separate them apart from each other, and especially what makes them different from isometrics. And so here you can see all 4 of those examples. Isometric drawn over here on the left. There are 2 types of obliques that you can have: cavalier or cabinet, and then perspective over here. So just taking a moment to kind of evaluate the 4 different views that you see, we notice that isometrics are starting kind of on a corner or on an angle of the part. Obliques and cavalier and cabinet obliques are both starting with a flat face, and then the depth is all being drawn off at the same angle. And then with perspective, this is a 1-point perspective. We'll have another lesson dedicated to identifying perspectives too. But here you can see it's starting with a front face, and then the depth lines are actually pinching towards each other, towards like some kind of vanishing point out over here, let's say. So defining characteristics, the thing that really sets it apart is isometrics always start with a corner, and then these folks are all starting with a flat face of an object. So it's one quick way to kind of identify the differences between them. Again, here it's going to talk about obliques. They start with a straight on view. Everything is either then drawn at a 30, 45, or 60-degree angle for the depth. Again, there are 2 common types. We have cavalier and cabinet. The difference between them is the depth of the object and how it's represented. So a cavalier oblique is drawn at like full depth or actual depth, let's say, and then cabinet oblique is drawn at half depth. I try to remember the difference between the 2 by saying, you know, the cabinets in my kitchen aren't deep enough. I can't fit enough things in them. And so because of that, it must be drawn at half depth. All right, here's just another example showing full height, full width, but we have some differences here in depth. And they say that the oblique cavalier actually appears deeper than it does in real life. And then the cabinet oblique is more realistic because the depth part is not as distorted. All right, and now these slides are going to go through a method of how to create oblique pictorials. I'm just going to page through this real quick so you can see it. A lot of our sketching techniques all relate back to this glass box idea. So kind of envision where your part would sit inside of a simpler shape, like a rectangle or a square, and then start with that with construction lines, and then from there kind of whittle your way into the part. So you can see here establishing overall size and dimensions with your glass box, and then starting to identify features on the part that you can then transfer into your sketch. Okay. Now for isometrics, the term isometric means equal measure. You have 3 adjacent faces on a cube that will share a single point. These edges converge on one point and appear as a 120-degree angle or 30 degrees from the horizon line. So you can see how these angles are kind of lining up. Again, everything starts from a corner, a point, or an edge with an isometric sketch. Here you can see we'll have height, width, and depth represented equally. You can do a top front right or a top front left. Of course, we can do the back, the bottom, or anything else, but typically we always do a top front right side view for isometrics. The only reason you would pick left is if there was a particular feature there that you wanted to make sure that you drew out. Recommendations for how to select your best front view. We talked about this a little bit before with concept sketching, but now we're adding some more rules to the list here. So when selecting your best front view, that means that your most natural position or use shows the best shape and characteristic contours, has the longest dimensions, the fewest hidden lines, and the most stable and natural position. So when you're dealing with different objects, run through that list and try to figure out what would be the best front view for me to make my sketch out of. And this will obviously be more important when we're making multi-views because you're selecting that front view and actually drawing the front view. Here, we're trying to select the front view and then draw the isometric of the whole part all at once. All right, and again, coming back to the box method, envision your part inside of there. That can be very helpful. It'll help give you better framing for your object. And here's a bunch of examples for that. So here you have an object that you're going to sketch. By reading the number of grid squares that you see imprinted onto the object, we can kind of estimate its overall height, width, and depth there, and then frame out that glass box. And then really we just have to have this little chamfer cutout so you can see the points here that are identified on our construction lines. And we will go ahead and connect those on a diagonal. And then from there, we actually have everything we need to start drawing in object lines and darken in the features of the part. And that would be it. There we go. One of the last steps then, which I don't really push too hard anymore, is tonal shading. If you're an artist and you can add tonal shading with your pencil or your pen to your objects and give them a little bit more depth and realism, that's great. But it's not a requirement because more often than not, I find that it detracts away from the quality of the sketch. So feel free to not shade your objects unless you absolutely want to. And you're confident in your ability to do that. Here's just another view, another object, starting with the glass box method. Get your overall height, width, and depth, draw out that box or that frame, and start identifying points on the object that you can then transfer over into your sketch. Darken in your object lines, make projections back and to the left, off and to the right, up and down in between your features until the part is complete. There's some really great examples at the end of this PowerPoint presentation, some historical examples for you to reference as well. And then the last presentation here is just how to draw isometric circles and arcs. It's a little bit trickier, so allow me to show you that for a moment. Circular features and cylindrical forms are common in engineering designs, and in an isometric will appear to be more elliptical than anything. And so in order to draw something like this out, again, you can start out with a glass box. We can do a little crisscross from the corners to get a center point there. And then from your center point, moving outwards, whatever your radius or your diameter is, you can start to make like little hash marks on your squared out construction lines. So now I kind of have, pardon, 8 contact points here. 1, 2, 3, 4, 5, 6, 7, 8. And between those 8 points of contact, I can start to draw out what my elliptical shape might look like. So these little hash marks are meant to help you. And then just do little portions of the curve until you are satisfied with how that looks. Darken in the object lines. From here, we can project downward and get some height for the object. Again, relying on those hash marks and just draw in portions of the curve one at a time until you get your entire shape. Got to connect the top and the bottom circles. And that would be a finished example of how to sketch out an isometric circle. All right, everybody, thank you for watching. In your activity today, you'll be practicing some isometric sketching and hopefully have some fun with that. Thanks for watching, everybody. I'll catch you next time.